All right, so we're going to finish up section 7.5, and on this video I'm doing solving log equations. So there are two types of log equations. One that's pretty easy to solve, that we've looked at before, where you just have log to the base 3 of x equals 4. And so this would be 3 to the 4th equals x. You just write it in exponential form and you get 81 equals x. So that's a really easy kind. Then you have the kind that's also fairly easy, where you have log to the base 3 of x plus 4 is equal to log to the base 3 of 2x minus 1. And so these are pretty easy too, because notice you have log to the base 3 of this is equal to log to the base 3 of this. So it's just like when you can scratch the bases, when you have the bases are the same and the things are equal, same thing. If you're taking the log to the base 3 of this and it's equal to the log to the base 3 of this, I can scratch the logs and I get x plus 4 equals 2x minus 1. All right, and so then subtract the x, and 4 is equal to x minus 1, add the 1, and I get 5 is equal to x. Now, you do have to go and make sure that you're not taking a negative number, the log of a negative number, on all of these log equations. So if I put in a 5, this would be 9, so that's positive. And if I put in a 5, this would be 9, so that's positive. All right, so 5 is my answer. All right, or if I have problem number 3, the natural log of x is equal to the natural log of 4x plus 1. Again, I'm taking the natural log of this and the natural log of this, they're equal, and so I know that the numbers I'm taking the logs of have to also be equal. So I can scratch the logs and say x is equal to 4x plus 1. Now, subtract 4x, and I get negative 3x equals 1, and divide both sides by negative 3. And I get x is equal to negative 1/3. Now remember, we cannot take the log of a negative number. And so if I try to put x is negative 1/3, I would be taking the natural log of negative 1/3. That's not allowed. So the answer here is the empty set. Okay? You cannot take the log of a negative number, just like you can't take the square root of a negative number. So those are the easier types of problems. Also, if we have something that looks like this, the natural log of x plus 5 plus the natural log of x is equal to 0. All right, so here I would have, okay, so these are the ones where it's starting to get a little bit more difficult, because first we have to write the logs together. So remember, when you're adding the logs, you multiply these two numbers. So it's going to be the natural log of x plus 5 times x, all right? So you're taking the natural log of all of that. So now let me distribute, and I get the natural log of x squared plus 5x equals 0. Now remember, the base here is understood to be e. So this would give me, writing it in exponential form, so here's where we have to go back to writing it in exponential form. I will have e to the 0 is equal to x squared plus 5x. Well, what is e to the 0? Anything to the 0 is 1. So I subtract 1 from both sides, changes sides, changes signs. And this one I can't factor because it only factors with -1 or 1 and -1. And I can't factor that and make it 5. I mean, I can't add that to make it 5. So I'm going to have to use the quadratic formula here. And so this would be x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Here a is 1, b is 5, and c is negative 1. So I'm going to do this really quickly. Negative 5 plus or minus the square root of 25 minus 4 times 1 times negative 1 over 2 times 1. So that would be negative 5 plus or minus the square root of 29 over 2. And so if I do the negative, this would be negative 5 minus the square root of 29 over 2. That's going to be a negative number. I can't do that. And so negative 5 plus the square root of 29 over 2, that is my only good answer. All right? So on these, sometimes you may have to factor, sometimes you may have to use a quadratic formula. All right? Let's look at another one. Problem number 5 says log to the base 3 of x minus 1 plus log to the base 3 of x minus 1 is equal to 2. All right? So this would be, again, we have to write this as a single log. So when I'm adding the logs, I'm going to multiply these two numbers. So it's going to be log to the base 3 of x minus 1 times x minus 1. So I'm taking the log of all of this. So this would be, foiling that out, I would get x squared minus x plus 1 equals 2, and then combining my like terms, x squared minus 2x plus 1. All right? So now I write it in exponential form. So here's my base, and my exponent is over here. So 3 squared is equal to x squared minus 2x plus 1. By the way, if you notice that this is a perfect square, you can leave it as x minus 1 squared, and you can work it like that and do the square root method. But most of y'all aren't going to see that, so that's why I'm working it this way. So this would be 9 is equal to x squared minus 2x plus 1, and subtract the 9. So now I'm going to look at the factors of negative 8. That's negative 1 and 8, negative 2 and 4. So negative 2 and 4 give me 2. I want negative 2, so that means change both of the signs. And so this is going to be 0 is equal to x plus 2 times x minus 4. So if x plus 2 equals 0, bring the 2 over, subtract the 2, you get x equals negative 2. If x minus 4 equals 0, add the 4, x is equal to 4. And again, you have to make sure that you're not plugging in a negative number for the log. So if I plug in negative 2 minus 1, that would be negative. So no good. But if I plug in 4 minus 1 is 3. 4 minus 1 is 3. So that's good. So this would be my only good answer. So you have to make sure that you are checking those answers. All right, problem number 6 says log to the base 5 of x plus 5, log to the base 2 of x plus 5 plus log to the base 2 of x plus 1 is equal to log to the base 2 of 5x plus 17. All right? So again, I want to write these two logs together, so as a single log. So I'm condensing them. And so that would be x plus 5 times x plus 1. is equal to log to the base 2 of 5x plus 17. So now I'm going to FOIL this out. So log to the base 2 of x times x is x squared, x times 1 is x, 5 times x is 5x, and 5 times 1 is 5. So now I'm going to simplify that. So I get x squared plus 6x plus 5 is equal to log to the base 2 of 5x plus 17. Now on this one, notice again, I have the log of something equals the same log of something else. So if these two are equal and the logs are the same, then these two things that I'm taking the logs of have to be equal. So x squared plus 6x plus 5 is equal to 5x plus 17. So subtract the 5x and subtract the 17. Right? So I get x squared plus x minus 12 equals 0. So now looking at the factors of negative 12, I'd have negative 1 times 12, negative 2 times 6, negative 3 times 4. And negative 3 times 4 gives me 1, and that's what I'm looking for. So I have x minus 3 times x plus 4 equals 0. So if x minus 3 equals 0, x equals 3, adding the 3 to both sides. If x plus 4 equals 0, subtract the 4, you get x equals negative 4. So again, we need to check and see if we're putting any negatives. So negative 4 plus 5, that would be okay. That would be positive 1. But then negative 4 plus 1 is negative 3. So can't do it. But let's check the 3. So this would be 3 plus 5 would be 8. 3 plus 1 would be 4. And then 3 times 5 is 15, plus 17 is 32. So this one works fine. Now, we also have a couple of word problems in this section. And the first one is a pH problem. And so let's do word problems. Problem number 1. If it says find the pH if the concentration of hydronium ions is equal to 6.5 times 10 to the negative 3. So the formula here is pH is equal to the negative of the log of the hydronium ions. And so this would be the negative of the log of 6.5 times 10 to the negative 3. And so I take my calculator and I'm going to go 6.5 EE negative 3. I'm going to take the log of that because it's the log of that number. And then I'm going to change the sign on it. So the pH here would be 2.19 if I round it off to the nearest 2 decimal places. All right? And then the second type of word problem says that Fred has a car and wants to buy a car, and right now he has $3,500. He knows that if he can put down a down payment of $4,200, then he can get a better interest rate. So he decides to put his $3,500 into a savings account, and he can receive 5% interest compounded continuously. How long will it take for him to get the 4,200? Okay, so we're looking for T. So notice, this is the principal. This is the amount that he's putting into the bank. This is the amount he wants to get out of the bank. The interest rate is 5%, which would be 0.05. Because remember, you're dividing by 100, so you're making your number smaller. You move it over two decimal places. Now, whenever it says it's compounded continuously, then that tells you that you're using A equals P e to the RT. All right? So when I'm solving this, I'm going to have 4,200 is equal to 3,500 e to the R 0.05 times t. Now I have to solve this equation. So first I need to isolate this exponential function. So I can cancel this and I'll have 42 over 35 is equal to e to the 0.05 t. Now I'm going to take the natural log of both sides, and I do the natural log because of the e here. The natural log of 42/35 is equal to the natural log of e to the 0.05 t. And again, this can come out here. And I get the natural log of 42 over 35 is equal to 0.05 t times the natural log of e. But remember, the natural log of e is 1. Then divide both sides by 0.05, and I get t is equal to, so on my calculator, I'm going to have to do it this way. Open parentheses, 42 divided by 35, close parentheses, and then take the natural log of that, and then divide it by 0.05. And so it would take him 3.65 years to save up the money that he needs to save up. And so that finishes off log equations.